So, okay. So I want to kind of come back, and we're going to come back a few times to basically doing the same thing, but more deeply. So analogously to how, in elementary school, you learn a little bit of arithmetic, and then in middle school, you learn a little bit more algebra, and then finally you get to ANSI, and then you really realize how rigorous everything is. Maybe you haven't yet, but so we're doing kind of the same thing. So we did kind of a first introduction the other day. Hello. And then now we're going to do one more time where we kind of do the same thing. And eventually we're going to get there together. So, all right. So one thing I want to point out is comments in Python. My screen sharing is paused. I do not wish for it to be paused. It is now not paused. So basically anything that comes after the hash sign, so the little kind of net thing, please do not call it a hashtag. A hashtag is like hash and then a tag on Twitter or whatever. This is just a hash. So that basically is ignored by Python, right? So I wrote code that will print the absolute value of n, just in English. Python doesn't care. In the same way that I wrote a comment after the hash over there, where it clarified for the human reader rather than for the computer that if n is negative, then minus n is going to be the absolute value. That is, in fact, a typo. It's just minus n. Minus n is not the absolute value of n if n is negative. So, okay. So we also spoke a little bit informally about the different types of objects, or informally, I will say, the different types of values that you can have in Python. So you can have something like 1, 2, 3, 4, 5. That would be an integer. In Python parlance, something like 3.14 would be called a float. So that stands for floating point. So that's because the decimal point can move about there. So that's kind of the source of the name. We saw two types of strings. So you can have a string like ANSI. So this would be enclosed in quotes. It can also be enclosed in ticks. Those are both strings. They are the same kind of thing. Why do you need the quotes? Like, why couldn't I just say ANSI without the quotes? Yeah, exactly. Because what we saw last time is that you can have a variable that's named ANSI, and you need to be able to distinguish between a variable that's named ANSI and the actual just text that says ANSI or praxis or what have you. You also have stuff that you probably haven't seen unless you've programmed before, like true and false. So true and false, this is not text. This is more like a number. It's a type of value. So specifically true is the value of the expression, for example, 42 equals 42. That would be because 42 is in fact equal to 42, right? So in the same way that 3 is 1 plus 2, 42 equals 42 has the value true. The type of value it is called Boolean, after the English logician George Boole from the 19th century. There is also false. Works the same way, except the opposite. So, like we mentioned last time, there are different rules, so we say semantics, for different types of objects. So, for example, times 3 does not mean the same thing for 12 and for ha, like we saw last time, right? So the way 12 times 3 works is, you multiply 12 by 3. The way ha works times 3 is you get ha, ha, ha. That was extremely amusing last time. So that doesn't necessarily generalize. So Python has rules about how the times thing works and how the divide thing works. And it so happens that the decision was made that times 3 does make sense, but you can't divide like a by 3. And well, you might imagine if it were anything, it would be a, the ones, but it's not. It would just give you an error. Make sense? Questions about this? Yeah. No, it will say this makes no sense. In the same way that it might have had said, well, actually, like ha times 3 doesn't make sense. Ha is not a number. It so happens that that does work. In general, there are rules about how you combine different types of values. Yes.
This is like 3a as a variable divided by 3, that would work, right?
Well, that's an excellent question. And the answer is, well, it depends on what kind of variable it is. So let's actually try it. So I'll go to Python tutor. And yeah, so please follow along with me. So I'll please the internet follow along with me. Okay. Yeah, so sometimes in those big rooms, the Wi-Fi can't really handle 300 people doing it at the same time, but we'll try. So the question was, like, yeah, like if you do like a divided by 3 and you try to execute that, it will just tell you that's an error. But what if AAA was a variable? Well, if AAA is, for example, 5, then yeah, totally. So you do AAA equals 5, and then AAA divided by 3 is whatever, 1.67. On the other hand, it could be that AAA was I love Praxis, this string. In that case, it would be an error, not because it's not true, but because AAA is a string and you cannot divide a string by the number 3. So the answer is it depends. All right. So that's the semantics. Other questions? Okay. So seriously? Okay, please. Okay, please just close it. So that is a lie. Just close your laptop, please. So okay. Okay, all right. I'm just glad that I'm not the only person for whom things are going wrong today. So okay. It's okay. Things are gonna be fine. So okay, all right. So we had kind of more complicated rules about syntax, right? And again, kind of the different thing between something like high school math and Python is that Python is strict about syntax, right? So if you make a typo when you're doing your calculus homework, nobody cares. If you make a typo where you don't follow the syntax rules exactly, the program just won't work. So an example that we saw from last time, and now we're trying to formalize it, is assignment. So assignment means take the right-hand side. So I wrote it as RHS there. So this is just notation, right? So angle, RHS, close angle, that's just right-hand side. And assignment means take the right-hand side and put it in the left-hand side. The rule is that the left-hand side must be a variable. It must be something into which you can put a value. The right-hand side can be any kind of expression. So again, and we'll kind of speed up at some point, but for now, we're going to be kind of slow. Is it pausing again? Why? Oh, resume share. So you can say something like A equals 5. You can say something like B equals to 34 and A is equal to B minus 7. Okay, so that's an expression. It could be an even more complicated expression, right? So times 2 or something. What's on the left-hand side must be a variable. So let's visualize that. So here I'm saying B equals 34. So the semantics of it, what it means is that I take 34 and I put it into B. So B is now 34. And now you have some kind of expression on the right-hand side. So 34 minus 7 times 2. Whatever that computes to, that is now going to be put into A. A is now 54. Make sense? So, okay. So that's the semantics of assignments. So we also just started talking about the semantics of conditionals. So that is kind of better expressed in the notes. Usually what's going to happen in this class is I'm just going to be typing in. It's just that for the first couple of classes, I'm going to be flipping between things because we're just introducing things. So this is the rules for the conditionals, right? So there has to be an if, and there has to be a condition. The condition must be, in order for the thing not to error out, something that's actually a condition, so something that's true or false. Then you have a colon, and then you have a block that's indented. So indented means that there are spaces over here. So a question that someone asked me after the lecture yesterday is, well, how do I know that block 1 has ended? The answer is the indentation stops. So here you can have one line or you can have several lines. And then the way Python knows that block 1 has ended is else is indented at the same level as if. So that was a lot of words. And at some point, I need to have said those words. So there you go. Mostly how you learn those things is you see how the example works. Like if you just listened and weren't looking, it would be probably difficult to understand what's going on. So this is the example that we had last time for the absolute value, right? So here we said, if this is true, we print n. If it's not true, then we go to print minus n. And in either case, we print the absolute value of n. So, okay, here is some more complicated syntax. So let's say that you have this example. So, you are thinking about what kind of grades you're going to get. And you want to say, I am happy if you get a 98 or more. And otherwise, you want to say, I'm feeling okay. And if you got a really low grade, you want to say, I got a low grade. So the way you can write it in Python is you can have the first condition. And if this condition is true, then the block is going to be executed. If the condition is not true, you check the second conditional. If this is not true, you check the third conditional, and so on. So let's write an example. So what I'm going to do is I'm going to copy this into Python Tutor, and I encourage you to do that along with me. And then I'm going to change the code in order for the example to work. So I'm going to set the grade to something. Let's say that they didn't do so well and I got a 94. And the first condition, I'm just going to make it up. I'm going to say if grade is greater or equal than 98, I'll say hooray. And then I'll check another condition. So I'll say if grade is greater than 95. Okay, 45 is a little bit below. I'll say okay. And if it's greater than 92, okay, at this point, we're like on track 1, I know. And then what is this? Okay. Okay. So what's the semantics of it? So I'm saying if grade is greater or equal to 98, then this is going to happen. If it's not, then I'm going to check this condition. Oh, and now people are taking, this is actually broadcast to YouTube. I don't care. Hi, president of TMU. Okay. So then if this also didn't check out, then I'll go to this line. And then the else is basically the default condition. The default human condition is going to TMU. Okay. There are worse fates. You could go to arts and science. Okay. So let's try to execute an interesting example. So I'll put the grade in as 93. See that the grade is 93. So what's going to happen is we're going to check this, and it's not going to check out. 93 is not greater or equal than 90. So that means that we are over here. So now we're saying, is grade greater than 95? The answer is it's not. So that means that line 5 is not going to happen. And we're going to go to line 6. And now we're saying, is grade greater than 92? Well, yes, grade is 93. So that means that we're going to execute line 7. And we printed track 1. Make sense? So there is a subtlety here, which is that the conditions are checked in a kind of cascade, right? So that means that if you have something like this, so by the way, I'm kind of used to this, but if you're not, so what I did now is I just pressed back so that I got the code back, and now I can edit it. So I could say something like this. Right? And is that going to do anything? Well, no. So even if grade is equal to 100, anyone, so what's the output going to be? Well, I kind of implied what it's going to be, but what is it going to be? Yeah, it's going to be just hooray. And the reason it's going to be just hooray is that what happens is we first check whether grade is greater or equal to 98. And that means we do line 3, and then nothing else is going to be checked. And it makes sense that it would be like that. That was the logic in the first place, right? Because if grade is equal to 100, it's like greater or equal to 98, and it's also greater than 92, and so on. Only the first condition that checks out actually gets the block executed. Does that make sense? Okay, so that's hooray, and we're done. So that means that if you rearrange the conditions, that can potentially change the output of the code, right? So if I again go back and I take this and I put it over here, that is now going to be different. Okay. That's not even funny to me. Okay. Okay, all right. Does this make sense? So there is one subtlety here. So I put the if there at the top, and then it goes if, elif, 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 and then the else. You could have multiple ifs in a row. So what you can have is something like this. So what would be the output right now? So let's maybe talk to your neighbor for a second to decide what it's going to say. Or you can try it as well. In fact, you should be trying it along. Yeah. Okay, all right. Just because it seemed like a long question. Okay, so what is the output going to be? Yeah. Yeah, well, so like more special than the average hang size and then hooray, right? So yeah. So why? Well, because the way Python runs is it executes line by line, right? So here we're saying, okay, grade is 100. So this is just if grade is greater than 99, print this. So this, the first 3 lines are just its own separate thing. And now we go into a new block of code, which is just if, elif, elif, else. So all of this goes together, and then this guy is actually separate. And you might say, well, like, didn't I fool you and not tell you that? Well, no, actually, I kind of did tell you that. It's just that, like with most things in programming, like the rules are simple. The problem is how do you apply them, right? So what this says is the if block is if, elif, elif, else. You don't have to have the elifs. You don't have to have the else. So the way Python understands the code is one if block that doesn't happen to have any elifs and doesn't happen to have any elses, and then another if block that has an if, an elif, an elif, and an else. All right. So, okay. Questions about this? So what everyone should be doing now, I think now that we've seen some examples, is just making sure that you type things in and made them work. And the reason is, like, if you're doing it for the first time, it's probably not obvious to you kind of that, you know, you have to have the column, you have to have the indentation and so on. So if you indulge me, please. So let's take 1 minute. And please, everyone writes just like what happens for 99 and what happens for 98. You can make up your own funny example that's funnier than mine. So if you already know how to code, please indulge me. Everyone else, please go to Python tutor, make sure that you've typed something that actually works and executed it. Yes?
If the first condition wasn't met because it's a separate block, would it stop or would it go on to the second?
It would go, yeah, that's an excellent question. So the question was, what happens if you just have this and the grade was not 100, right? So, and the answer is, well, this gets executed if this condition is true. If the condition is not true, it just doesn't get executed. So here's an example. So I'll just print high over here. And I'll make this be, everyone please type something in and make sure that it works by pressing visualize execution. Once is bad luck, twice. And so, okay. So, okay. So what happens now is it says, is grade greater than 99? no, that means that the print is not going to get executed. And we just go to the next line of code, which happens to say print hi. So hi is going to get printed. Yeah. The question, the way people usually express it is, are the names of the variables case sensitive? And the answer is yes. So we'll go into kind of rules about that later on. But so what this means is that grade and grade with the big G are different. So there's like multiple things you could ask about this. You could also say like, like, am I allowed to have, spaces and variable names? The answer is no. Can you have underscores? The answer is yes. But we'll go into those rules later on. For now, just kind of keep things consistent. All right. Okay. Who has written code that's like that ran? What's everyone else doing? Okay, so do this example, if nothing else, make sure that it works. It's really important. So the way people don't succeed in the course is they don't write code. So let's everyone just try this. We'll also do practice in the lab. Yes.
Else statement. You wrote else colon the hashtag default condition. What does that mean? What does it do?
So so the semantics of this is, if condition 1 holds, we execute block 1. If it's condition 2, then block 2. If no condition holds, then we execute this block.
Right.
So else is the default block that runs if nothing else has checked out. Yeah.
Why do people put else? Like the one.
Then nothing happens, right? So you don't have to write any code, and if your program is empty, nothing happens. So you don't have to have the ellipse. That was the first example that we had, and you don't have to have the else. Make sense? Okay. Other questions? Yes. Okay. Yeah. Next week. Okay. So the answer is, in Python, you can literally say and it works. How it works will defer to next week. Yes.
A way to say from this number to this number, or should you just say greater than or less than?
There is a way, and this is related to what you asked here. So you can say, for example, so you can also say like 1 smaller than x smaller than 5. That happens to work in Python. But there are ways to combine conditions. For now, we haven't done that. Okay. 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 Is everyone done typing in an example that works? Who is done? Okay, that's not quite everyone. All right. So 30 more seconds. Really important to get it to get something to work. If you don't do it in the next 30 seconds, please do it over the weekend. All right, I hope you're done. Yeah, so in the lab, we're going to force you to finish the exercises. Okay. So I want to write something that's not just like automating Steve and Irma, the student advisors, which is what this was, I guess. Let's write a quadratic equation solver. So what I'm going to do here, so this is referred to as commenting out. I'm just going to make this all into a comment, which means that Python is just going to ignore it. So, okay. So the way I'm going to do it is I'm going to set, the input like this. So this is still a comment, right? So ax squared plus bx plus c. And what I want to do is I want to write code that's going to solve the quadratic equation, right? So I need to first input the coefficients. Make it a little bit larger. By the way, are people in the back fine with this font size? Okay, all right. If there's problems, please complain. So I'm going to say, for example, a equals 1, and I'm going to say b equals 2, and I'm going to say c equals 1 or something. And now I want to solve it, right? So the quadratic formula looks something like this. So I'll write like plus minus. So like people usually write something like this, right? So in Python, you cannot use the caret for the power, and for a C doesn't make sense. If you want to say times, you need to say times. So I'll write it out kind of a little bit more carefully. So one more thing that I need to tell you is how to do square root. So in Python, you can write powers as a to the well, x to the power of y. Let's say well, x. Let's say z to the power of p, something like that. So you write powers using the 2 asterisks. All right. So okay. So I'm going to write the discriminant. So the discriminant is b squared minus 4ac as b squared minus 4 times a times c. And now what I need to do is I need to apply this equation, assuming I can, right? So I cannot do that if the discriminant is smaller than 0, right? So what I'm going to do is I'm going to say, okay, so if the discriminant is smaller than 0, I'm going to say there are no real, I should say, there are no real roots. Sad face. So what is the other situation? Well, it could be that the discriminant is 0, in which case there is 1 root, and it could be that the discriminant is greater than 0, in which case there are 2. That exactly works with our template for if, elif, else, right? So I'm going to say elif discriminant is equal to 0. And I'm going to print, so minus b divided by 2a. And then here, I don't have to explicitly write discriminant greater than 0 because that's the only possible, the only other possibility, right? If discriminant is not smaller than 0 and not equal to 0, then it's greater. And in this case, there are true roots. So let me compute them. So R1, I'm going to write as minus b plus discriminant to the power of 1/2. So this would be square root discriminant divided by 2 times a. And I'm going to say R2. What I'm on shift and then pressing end, and that selects everything. So probably most people are not used to this kind of thing. It's good to get started on keyboard work now because this is much faster because I can kind of do it like this, right? And what I did was select, so shift end on Mac, it's command right. And then I just did Control C, Control And here I changed it to minus b minus square root of discriminant. Yes. So on a PC, it's shift end to select until the end, shift home to select to the left. On a Mac, it's command shift right, command shift left. Okay. There is a button that says end on my lap, so it's usually like in the top right corner. Make sense? So, okay, so it's got to be different to the different keyboards. So now I'm going to print R1 and I'm going to print R2. And that's our little quadratic equation solver. Make sense? So one thing that we kind of have seen but kind of haven't is a block that's more than one line. So here what I had done was I just said, well, I need to compute R1 and I also need to compute R2, and then I want to print R1 and then I want to print R2. So all of that is going to happen inside the else. So to remind you, the condition was if the discriminant is smaller than 0, I say no real roots. If it's equal to 0, I print the one root. The other possibility is there are two, and I first compute them and then I print them. I didn't have to do it like that, right? I could also just put in the formulas directly. Just show, and there are always multiple possible ways to do it. I'm going to let people get a little bit of time to type it in. This is also in the course notes, but again, kind of typing things in, making sure they work is really essential. So in the meantime, I'll just remind you that x plus 1 squared is equal to x squared plus 2x plus 1, which means that the root is minus 1. So what I would expect with a equals 1, b equals 2, c equals 1 is for there to be one root, which is minus 1. Make sense? So, yeah.
Like whenever you say print, is the whole thing have to be a bracket? And if you say like R equals 1 or R2 equals whatever, does that not have to be in?
Yeah, that's an excellent question. And the answer is that assignment works this way. It's left-hand side equals sign right-hand side. And it means take the right-hand side, put it in the left-hand side. Print is a different thing, right? So print is output something to the screen.
Whatever that is to R1.
That's correct. Yeah. Yes. So this is saying compute this, put it in R1. So let me first run the example with the one root. So we are over here. I'll make it a little bit smaller. So we are over here. So we put 1 into A, 2 into B, 1 into C. The discriminant is 0 as expected. So not smaller than 1. We're now comparing it to 0. It is equal to 0. So that means that we're printing minus B over 2A, which is minus 1. Lucky day. Yes. So the answer is, again, going to have to be slightly deferred to, I guess, next week, because we're like 8 minutes away from the end of the class. But the question was, why does it say 0.0 and not like 0.00 or something? And the answer is, well, first of all, it just displays it like that. It doesn't mean that that's what it thinks. What it thinks, we'll also talk about, possibly not right now. All right, other questions? All right, so let me just kind of model good practice and actually check that it works for other examples as well. You know, how do I come up with A and B and C such that there's an interesting answer? Well, I can do like, you know, what's x minus 1 times x plus 2 or something. And that would be x squared. So you have like minus x, you have plus 2x, right? So this is plus x minus 2. So this would be 1, and this would be 1, and this would be minus 2. So let's try that. So the discriminant is now 9, which means that there would be 2 roots. So it's not 0. We are over here. We'll compute our 1. Our 1 is 1. We'll compute our 2, minus 2, and we'll print 1 and minus 2. All right. Questions? All right. So there is a little bit of time to answer your question, and might as well do it now, or at least start the introduction to that. And that is about how numbers are stored in the computer. So that's those nodes over here. So you kind of anticipate it. So the way Python stores integers is basically what your intuition would tell you. It stores digits. They're not decimal digits, but nevertheless, it is digits. And unlike in, for example, Java, if you've had Java, Python has an unlimited number of digits that it can store in an integer. In practice, of course, you know, like nobody has infinite memory. So like eventually, you know, you'll run out of memory and you'll get like threatening messages about your computer running out. But in practice, basically most of the time, you know, you can have this number, which I believe technically is a bajillion to the power of bajillion, and that's just going to be stored, and you can print it. So unlike with integers, floats, so in kind of middle school language, fractions are stored using a fixed number of digits. So that means that there is, and it depends a little bit on the hardware, how many digits exactly. But basically, if Python is storing a float, that means that it's storing, first of all, basically a number in this format. So a times 2 to the power of b. And then a can have a certain number of digits and b can have a certain number of digits. So for that reason, or at least for a reason that's related, when Python prints a float, it tries to figure something out, but it doesn't have an infinite number of digits. So it's going to, in practice, round things. So we're going to talk more about that next time. So for now, I just want to, and some of it is going to be a little bit advanced, and that's a good reason to point to the just for fun links over here. So like if I mention anything that's not really exactly, you know, in the course material, but it's kind of fun, I'll try to point out, okay, this is just for fun. And then sometimes there's going to be links about that. So you mentioned the fundamental theorem of arithmetic last time, and we mentioned the Chomsky stuff. So you can read about it on your own free time. There are readings. So there's 2 textbooks, someone asked. So the textbooks are not mandatory. However, if you find that you learn better by reading, there is readings over there. There is some learning outcomes that are going to be updated around the end of the week. You can't always tell how far you'll get in the lecture. Okay, all right, you're almost done with the first week. I am done with the first week. So I'll see you next time. Bye. Oh, we're done for the first weekend. Yeah.
This one's so hot. Oh, please go.
Thank God.
Okay, bye-bye.
Like that, like what, like. So that's actually it's the question. Technically, with the complexity would be about, I think, if you want to compare 10 zeros and 10 and have 8 digits, well, you need to spend kind of what a now in general, we kind of say, okay, like probably n is not too large, and in that case, like you say, it's all one. And for those kinds of examples, like unless there's something special going on, or think about it, and like say that looks like its own one. But technically, yeah, like if it's an integer, yeah, like it could take a long time to compare to 0 as well. Right? Yeah. Yeah, so so there's going to be exercises that are going to be posted later on. It's just tough to do exercises for the first year class. If you Google something that EAT, there's Python exercises. With that said, the reason they're not posted currently is that there's not a good selection of different. But starting that, I think they're built. There's no quizzes until it's 30. No.
Like the roof?
Yeah. So for that, we need to well, one or the other. Sometimes it comes straight to the first well. But yeah, so printing, yeah, so you can print one. not necessarily. That's good. No, so, those are two different things, right? So you kind of do strength plus integer. You can do comma, yeah. But that's separate from kind of print, right? So you can print any value that you want, and that's what you say. You can print a bunch of values if they're separated in commas. So that's next week. So the plus thing is separate, like it's, you see, like it's like conceptually completely separate from whether you can print it. You can like compute 2 plus 3, you don't have to print things. Yeah, so you cannot add strength plus flow, and that means you have right strength plus flow, but that's because you can add it. So yeah.
Print and then like you put it into apply and plus and
That's you can do you can do okay, like in practice, yes, you can do comma. It's not like instead because they're like separate things. But like the way I would put it, what you've done is what I was wanting to teach, which is like you can print her 1, you can then print high. For now, the way you would do it is you would just print them on 2 separate lines. Yes, you can separate them.
So like, if you did plus, it'd be concatenating commas, just separate.
Or,
what would say, well, like, I think.
well, we do lots of
Also, for like our exercises, will you be using Python tutor or on top?
So I will make you use Python tutor for tracing your code. So kind of the reason I do Python tutor is because I think it's like really nice for kind of showing what's going on. There's other tools as well, but like it's very straightforward, I find. And sometimes in the lab, I will like make you trace your code because I find that they become.
Does it,
But in general, you'll just be writing code and yeah. We'll start there.
in general, okay, so like, does Python tutor support like a complete set of Python?
Yeah, there's like
Like I
a
tried to do the
small
help function.
amount of stuff that doesn't work. Yeah, so like it's not like meant for kind of having to code.
It's for learning.
Yeah, well, for learning.
So for like our projects, where you'd be using IDE as.
Yeah, so kind of technically for the project, you like submit whatever you want to do. Right, it's like you can like type it like that. Yeah, like we will be switching to an IDE. It's just that for the first couple lectures, I wanted to type it from there.
Thank you very much. Have a good day.
I learned C# and I submitted to C# I don't look at what ID should I use?
So I mean, so we are going to be using ESC180. I think so. It's like
Yeah, that's
you
what
can do it like you can do it, right? So and I think like there is value in kind of learning multiple lines.
Oh, okay.
Yeah, I don't remember so. I believe it's cute there.
Maybe I was not looking in the right place.
Yeah.
Oh, I think I was looking at the calendar instead.